Okay, this problem is starting with number 29. Okay, so pause this and read number 29 if you need to. I've actually already closed my book, so I don't even know what it says. I wrote this down yesterday. So when I read 29, what I got out of it was that the final horizontal velocity was 7.5 meters per second. It took 4.5 seconds to get there. The initial horizontal position was 0, and it covered a total distance of 19 meters while going from whatever velocity to 7.5 meters per second. Okay? And it's asking me to find the initial horizontal velocity. Okay, so as I go through here, I see that I don't know acceleration, so I can't get Vx0 here. And of course, you probably already know by now, if you've been working all these problems, if you don't know acceleration, it's hard to get anything. Okay, if you didn't watch problem 28 at the end, that might be helpful for this problem as well. So, I'm looking for Vx0, and here are some things I'm thinking. On the last video at the end, I showed you that you can get the average velocity if you add the initial velocity plus the final velocity and divide by 2. This works when you have a constant acceleration, which in this problem it said that we do. So you can add the initial and final and divide by 2, and it gives you the average. Okay. Also, I know in my head, because I don't know the average velocity, I know this, but I don't know this, so I have two unknowns here, so it's not getting me quite anywhere yet. But I also know that average velocity is equal to the change in x divided by t. Okay, so if I can equate all of these things, that means I can pick two segments and work with them. So I'm going to pick these two segments and solve for Vx0. Okay, now if you know what you're doing at this point, pause the video and work it out. Okay, so back to this from here. Let me get going again. I've got Vx0 plus Vx divided by 2 equals change in x divided by t. Okay, so I want to get Vx0 by itself. So here's what I'm going to do. Everything is divided by 2 here, so I'm going to multiply both sides by 2, and that's gone. So now I have Vx0 plus Vx equals 2 times the change in x over t. Everybody with me? I'll just move the 2 right here in front. I just like my numbers in front. Okay? Now, my next step to get Vx0 by itself, I'm going to subtract Vx from both sides. Okay? So that's gone. So now Vx0 should be equal to 2 times the change in x over t minus Vx. I'm going to use my crosses, and I'm going to pay attention to units to make sure that I rearranged correctly. If I did rearrange correctly, I should come out with meters on top and seconds on bottom. So I'm going to move my crosses. Let's see here, kind of running out of space. Okay, so I've got 3 variables here, 2, an x, and a t, right? So 2 times delta x, that gets its own spot, its own apartment, and change in x is final minus initial. So 19 meters minus 0 meters is 19 meters. And then t gets its own apartment, but it goes on bottom in its apartment because that's where it's at in the equation. So divided by 4.5 seconds. Subtracting Vx, 7.5 meters per second. So I'm going to end up with meters per second here and meters per second here. So 2 times 19, I'll plug it in up here, 2 times 19 divided by 4.5, okay, and then I'm going to subtract 7.5. So it should do the multiplication division before it does the subtraction, because the calculator does things in the correct order of operations. So I get 0.944. Okay, I don't even have the answer with me, so I hope this answer's right. If it's not, then yell at me in class tomorrow. Crockett, you totally messed up, etc. Okay? I'm going to do that in parentheses again. I don't trust my calculator. We have trust issues, but I think it's right. But you have the answers, so you can look it up. Get the same thing even with parentheses. See, I was having trust issues, but I still get the same thing. My calculator will multiply and divide, so I should have that right. So about 0.94 meters per second. Now, if you look it up in the book, remember it might say 9.4 times 10 to the negative 1, and you're going to start to get mad, but remember that's an exponent, so I got it right. Okay, so that's 29. I'm going to jump off here before I lose this video, since my video thing is having issues today, and I'll do 31 through 33, hopefully all on one video. We're going to try.